nickel, aluminum, selenium, and hydrogen and oxygen and nitrogen and rhenium and nickel.
This is the periodic table. It shows all of the elements that we know about. And we know that in an element all the atoms are the same. So here's hydrogen. So all hydrogen everywhere has exactly the same type of atoms in. And atoms are tiny, tiny, tiny particles. And just to give you an idea, here's a ruler. So if I was to look at just 1 millimetre on the ruler, then across that 1 millimetre there would be 5 million atoms. Okay. What I want to do is I want to be able to look at the way in which atoms join together to form molecules of compounds. So for example, when hydrogen reacts with oxygen to make hydrogen oxide, which we more commonly know as water, can I work out just how many hydrogens will join with how many oxygens each time that happens? Well, the answer is I can, and to do that I'm going to use a model. I'm going to, in my model, I'm going to imagine that atoms have little hooks on and that they join together by linking these hooks. And I'm going to say that the number of hooks that the atoms have depends upon which column the atom is in the periodic table. So this is column 1. So everything in that column has just one hook on. This is column 2. So everything in this column has 2 hooks on. I'm going to ignore this bit in the middle because they do some funny things and you'll come to those later in your science career. So we'll go to here, column 3, column 4, and then so that's 1 hook, 2 hooks, 3 hooks, 4 hooks, and 4 is the greatest number of hooks we can have. So then it starts going down again. So 3 hooks, 2 hooks, 1 hook, and no hooks. So I'm now going to have a look at my hydrogen oxide and see if I can work out how many hydrogens join with how many oxygens. So I know hydrogen here has 1 hook on and oxygen has 2 hooks on. So let's start by drawing a hydrogen atom with 1 hook on, and that's going to link onto an oxygen atom that has 2 hooks on. Now the rule is that you can't have any spare hooks. All the hooks must be joined onto the hooks of another atom. So I've got to join something onto this hook here. And so, because it's hydrogen oxide, there are only 2 types of atoms involved, hydrogen and oxygen. So I'm going to put another hydrogen here. So that's it, all the hooks are used up. So I've got 2 hydrogens with an oxygen. So I can write a formula to summarise that and say it's H with a little 2 at the bottom means that there are 2 hydrogen atoms, and an O, now we could write a 1 there but we actually miss it out to mean there's 1 oxygen atom. So that's now the formula for water or hydrogen oxide, H2O. Let's try another one. So going back to my periodic table, I'm going to look at, say, magnesium and chlorine. Okay, so magnesium is in column 2, so it must have 2 hooks on, and this chlorine here over here has just 1 hook on. So let's start here with my magnesium. There's a magnesium atom, and that's got to have 2 hooks on. And let's put a chlorine atom there. Chlorine's just got one hook on, so that occupies that one, so I need another chlorine to fill that one up. So that means I've got one magnesium atom joined onto two chlorine atoms, so I can write that as, there's Mg, and I could write the 1 but I don't, I miss it out, and then Cl with a little 2. So there's the magnesium chloride, and there's the formula.
There's antimony, arsenic, aluminum, selenium, and hydrogen and oxygen and nitrogen and rhenium and nickel.